Our next question is quite an unusual one. A construction toy consists of identical rectangular sheets of plastic. Melanie uses 16 of the plastic pieces to make the cuboid. The 3 hidden faces are made in the same way as the 3 faces shown. There are no gaps. And we can sort of see that here. So we've got 1, 2, 3, 4, 5, 6, 7, 8 plastic pieces on show. 9, 10, 11, 12, 13, 14, 15, 16 hidden on the other 3 faces. There are no gaps. Given that the surface area of the cuboid is 288 square centimetres, work out the volume of the cuboid. Well, because I know it's made of 16 plastic sheets, I can work out the area of one sheet. So the area of one sheet is going to be my total area, 288, divided by the number of sheets, 16. 288 over 16 is equal to 18 square centimetres. So I know that one of these sheets is 18 square centimetres. Let's call the width here x, and therefore we'll call the height y for now. So what I could say is that x times y is equal to 18, but that's no good because there are 2 unknowns there and I only have one equation. So instead what I need to do is look for some other way I can relate x and y. And if I look at my diagram, I can see that 2 lots of x on my diagram is equal to 1 lot of y. So that is, this y here can become 2x. And so now the area of my sheet is 2x times x, which is 2x squared. So 2x squared is equal to 18, divided by 2x squared equals 9. X must be positive, it's a length, so x is the square root of 9, the positive square root of 9, which is 3. That now lets me find my volume really easily, because I can say that this length here is 2 lots of x, 6 centimetres. This length here is 3 lots of x, 9 centimetres, and this length here is one long side, which is 2x, 6 centimetres. So my volume is 6 multiplied by 9 multiplied by 6. 9 multiplied by 36 is 324 cubic centimetres. 324 cubic centimetres. Lots of other ways to do this, but I think that's a nice systematic way to break it down. Always looking on the diagram for clues to help us. Question 10. The graph shows the distance travelled by a motorbike during the first minute of a journey. You've got distance in metres, time in seconds. Work out an estimate for the highest speed of the motorbike during this minute. So you know that speed is distance divided by time. In other words, y divided by x. So the gradient of the graph is my speed. And we want the highest speed, so the largest gradient. So I look on my graph for the largest gradient. Well, the largest gradient will be the steepest point on my graph, so roughly here. And I want to estimate that gradient. Well, I estimate the gradient of a curve by drawing a tangent to that curve and finding the gradient of that tangent. So that's exactly what I'm going to do. I'm going to take this point, line my ruler up, and I'm going to draw a straight line, and I'm going to span as far across the axes as I can. There's 2 reasons for that. Firstly, it's really easy to read off my change in y now, because it's just from 0 up to 1,100. And secondly, the percentage error of like me having a thickness of a pencil and misreading a tiny little box is going to be much smaller. And now what I'm going to do is find my gradient. Well, my gradient is my change in y. So let's start here and go down to here. So I'm starting at 1,100 and going down to 0. And then let's start at my time, which is at 45, 46, 47, 48 seconds. And we're going down to here, which is at 12 seconds. So I have 1,100 divided by 36. We are only looking at an estimate, so 1,100 over 36 gives me approximately 30.6 metres per second. 30.6 metres per second. There'll be a tolerance on this, so drawing, I could probably get a slightly steeper line if I move slightly further down, and there'll be slight tolerance on reading these values out as well. But you should have something around about sort of the 30, perhaps up to about 35 mark. I'm slightly underestimated here in reality. Very physicsy question there, but hopefully relatively straightforward and quite generous mark scheme tolerance in general as well.